Welcome to aminacademy.com. In chemistry, let us discuss about molar enthalpy changes. The amount of heat energy absorbed or released for every mole of the substance which reacts is known as the molar enthalpy change and is represented by delta H. Notice that the unit for delta H and Q are different. Delta H is given in kilojoule per mole and Q is given in joule. Here delta H, that is enthalpy changes, that is joules per mole, is equal to Q, that is heat energy joules divided by number of moles. Because the enthalpy is the total energy of the system, it is an important quantity. However, the only way to measure energy is through a change. In fact, there is no way to determine the true value of H, but delta H can be measured as the change occurs. The enthalpy change for 1 mole of a pure substance is called molar enthalpy change. Molar heat capacity governs the changes. The iron that blacksmith uses does not change state and is not involved in a chemical reaction. So the change in enthalpy of the iron horseshoe represents only a change in the kinetic energy of the iron atoms. When a pure substance is only heated or cooled, the amount of heat involved is the same as the enthalpy change. In other words, delta H equal to Q for the heating or cooling of substance. So the molar enthalpy changes is related to the molar heat capacity by the following equation. Molar enthalpy change equal to C into delta T. Molar enthalpy change equal to molar heat capacity into temperature changes. Now let us do one example problem regarding this concept. How much does the molar enthalpy change when ice warms from minus 5.6 Celsius to minus 1.8 Celsius? C for water is 34.4 joules per Kelvin mole is given. Here, two temperature is given, initial temperature of the ice and final temperature of the ice. Then you have to find the enthalpy change. Here, let Ti, initial temperature, equal minus 5.6 degree Celsius, and final temperature T final equal minus 1.8 degree Kelvin. It's not degree centigrade, it is a degree Kelvin. Now both they have to convert in degree Celsius, which is equal minus 5.6 plus 272, which gives 267.4 degree Kelvin. Here degree Celsius is given. Degree Celsius is given. Now we have to find conversion of degree Kelvin of this, which is equal minus 1.8 plus 272, which is equal 271.2 degree Kelvin. Now change in temperature, that is delta T, equal to 71.2 minus 267.4, which is equal 3.8 degree Kelvin. Now change in temperature is given. Now we have to find enthalpy for what we have to find how much is the molar enthalpy change. Delta H molar enthalpy changes is equal C into delta T. C is given as 37.4 into delta T is 3.8, which is equal 142 point 142.12 1.2 joules per mole. Further, this is equal 0.14212 kilojoule per mole. Next question, next topic, that is enthalpy changes of endothermic or exothermic process. If a reaction releases more energy than it's absorbed, the reaction is exothermic. That means the reaction releases more energy than it absorbs. This reaction is exothermic and enthalpy will be negative. Think of this as an amount of heat leaving or being subtracted from the reaction. If a reaction absorbs or uses more energy than it releases, the reaction is endothermic and enthalpy will be positive. Here, this is the exothermic reaction, this endothermic reaction. Heat energy flows inside endothermic reaction. Heat energy flows out, it's an exothermic reaction. Next, we'll discuss further about this one. Enthalpy changes of endothermic or exothermic process. Notice that molar enthalpy change for the problem we can understand about it's exothermic or endothermic. This enthalpy changes is positive, which means the heating of sample requires energy. So the heating of sample is an endothermic process. Here the previous problem, that ice warm up, so it needs energy, heat energy from outside. In contrast, the cooling of a sample releases energy or has a negative enthalpy change and is an exothermic process. Enthalpy of a system of several substances. The standard enthalpy of a formation of a substance is the enthalpy change that occurs when 1 mole of the substance is formed from its constituent elements in their standard states. A pure element is in its standard state has a standard enthalpy of formation of 0. You can read about how a substance enthalpy changes when the substance receives energy as heat. Enthalpy change can be found for a system of substances such as some reactions shown. Hydrogen gas reacts with bromine liquid to form the gas hydrogen bromide, that is HBr, and to generate energy as heat. Energy transfers out of this system in the form of heat because the enthalpy of the product is given. The enthalpy is the first and 3 thermodynamic properties that you will encounter in future. Thermodynamics is a science that examines various processes that the energy changes that accompany the process. By studying and measuring thermodynamic properties, chemists have learned to predict whether a chemical reaction can occur and what kind of energy change it will have. So far we have done about enthalpy changes in reactions, that is molar enthalpy changes we have done. Please subscribe our YouTube channel.